Hi there everyone, welcome back to STEM Lockdown Digital School, and today we're going to continue with SQL and teach you more about how to use your select. So by the end of this series of lessons you should be able to complete question 2.1 of your final exams, and this is just an overview of what I'm planning to do today. So is, nil, in, like, distinct, and then hopefully we'll get to populating the combo box. Now, before I go back to the book to show you the code, I just want you to take note of an empty style like this. So this is what I mean when I say a null value. That is a value that has not been completed in a certain field, and we're able to find those values, or we can also find the ones that have been completed that would exclude that value. So if we have a look at this code here, remember we're still going to have a select and a from before our where clauses, but we can find those empty values by using where, and register class would be a field name, and then you just write type is null. So you don't have to put an equal sign, and that will find you all the records where the field register class were not completed. So is not null does the exact opposite. So if I say where register classes is not null, it will find me all those register classes that did have values in them, and it won't show me the empty values. Just remember that a space is also a value. So when you're creating your own database for your path, careful of entering a space in a value, as Delphi will see it, but you won't, so you might be very confused. And then we have the in operator. So you had the in operator in the if statements as well, but when we use it in the if statements, we could only use ordinal values. Remember, ordinal values are chars and integers. When we're using the in operator in SQL, we are able to use it with any data type. So that is quite handy. In your where, you're going to put the field name, and then in, and again, this is a little different because in our if statements, this bracket here would be a square bracket, but in SQL, it's a round bracket. And then I will list my fields here, or my values here, separating them with a comma. Important that you keep note of what the field data type is of this field. So for numbers, no quotes, and if I have a field like, for example, subject, these values here will need quotes around each value. And of course, then for DateTime, you'll need hashes around them. Unfortunately, the dot dot does not work. So in your if statements, you were able to use the in operator to indicate a range, like from 10 dot dot 12, that would include 11. But here it does not work. You have to use them separately. So I've just also included here an example for you on how to use not. You will put a condition inside. You see the purple brackets, they'll put a condition on the inside of the not. So this statement will show me all the records where learners were either in grade 10, 11, and 12, and their subject was either maths or IT, and they were not in a register class A, C, or E. So now we get to statements where we can use some user input. As a suggestion, I would just store numbers and currencies all as strings, because remember our .text data type needs a string data type. So if you stored this here as iGrade and you said string to int iGrade, then you have to int to string it again here. You can imagine yourself just writing a statement in a caption of a label, and that's the same format we'll use in here. So if it's a number, remember we don't need quotes. So here I am showing the learner name field, the surname field, the grade from a table called TBL class, where my grade field is equal to what the user entered. Now this bit here will have to be in inverted commas. That's your hard code for your select. And then I add to that my variable sGrade. And whatever the user entered will be used in here. So if they entered 8, I will see grade 8 learners and so on. Now remember, with our text data type, we need quotes. And I'm first going to show you the second one here. Let's say the learner name we wanted to query, and we have user input from the user for what the learner name is. We can do it the long way by putting quotes there. Then you end your string for the .text property there. Add with a plus as your variable, and then add to that hardcode. So you start your inverted comma there, double quotes, end that line. Or you can use a function called quoted string, which is quite easy to use. So instead of doing this, you can say equals to plus the function quoted string and put your variable on the inside there. And quoted string will do all of this for you. We can also get input from the user for a date. Could be through a DateTime picker or maybe a date function. And if I'm querying a DateTime data type, remember you guys have to add hashes around the value. So let's say the user entered something in sDate. We had to then DateToString the value to store it as a string. We can also use DateToString in our code here. But you would have to first put the hash, then end that line of string, add your variable, then start your new string after your plus, add your hash, and then end the line of string there. And there you can also use between, and then it gets quite hairy. There's my hash, there's my first date. This is the hash that goes with this one here. Then and start the hash for the new date, and there's the hash for the second date. There is a function called BootToStream. You probably haven't used it before because it produces a number. But the user what the user sees is between our select and our from. They don't actually see what is in the where. That's just our condition to say which records to display. So we can use BootToString for Boolean data types. This is an example of a Boolean variable that I probably stored before this. So I'm saying where paid, this is a yes/no field, is equal to what is stored in there, but using BootToString so that I'm able to add it to my text property of my SQL. You can also use a .check property of a checkbox directly and then just BootToString that. If the user then clicked on this checkbox, we will say where paid is equal to true, and if they didn't select the checkbox, it would say where paid is equal to false. And then we have this very handy function called RecordCount. What is important with RecordCount is you first need to run a select. So my select statement here is just showing me all the grade 10 learners. Important that you have your dot open after this line. And then you are able to use your query name, the one we're using there, dot record count. And that will hold the number of what we call the active records. In other words, the records where the condition grade is equal to 10 were true. And I can store that as an integer, as record count returns an integer data type. And now I can use inum further down in my code. Next is the like operator. So we could say we type like, and you'll see like always has these double quotes, a value, and then we put a percentage sign in a certain position and end the quotes. So this percentage sign represents any number of characters. So if I run this statement, I will find just car, because percentage sign could also mean no characters. So I will find records where the type was just car, or maybe car space sales, or maybe just cars. So we can move this percentage sign around. If we have a look at this example here, if I put it in the front, I will find GP, or maybe a bunch of numbers and GP at the end, or some characters and GP, or something and a space and GP, as this represents any number of characters. It is important that this field here is either text or date time, And there's no equal sign here. You just put the field name and then like. And very important is that this percentage sign is on the inside of the quotes. Now, it will find, remember SQL is not case sensitive, so it will find capital GP, lowercase gp, or only GP. Then we can have maybe a question that's asking us, show us all the records that contain a double O in their suburb. So contain means that it can start with the OO, so having the percentage at the end, or it could end with a OO, or it could just be OO, or it could be somewhere in the middle. So this will find any instance of any one of these that I've bulleted down, starting with OO, having the double O in more than one place, ending with OO, or just the double O as well, regardless of the data type. We can also apply the like to a DateTime data type. But when you're using the like with the DateTime data type, you're not going to put hashes there. You are going to put your double quotes there. And what this is finding is any date that has in the middle, it has a /07/. So it will find the month of 7 for me. But there is easier ways to query your DateTime data types. You can say where month and then you have your date of birth is equal to 7. So month is a function, and we're going to learn in our next lessons more about functions in SQL, but this is just one of them that will extract the day of the month number for me from a DateTime data type. So these two statements will be doing the same thing. I prefer this bottom one. It's easier for me to type and I make less mistakes this way. So using the like with input from the user does become a little bit more complicated. You just have to imagine yourself hard coding it and then try and work your variable in there. Here I have my field name like, then the double quotes, then the percentage sign, ending my line of string there, adding then my variable, plus, and remember add the double quotes at the end in a string. I can also use quoted string, but what is important in this instance is that the percentage sign is on the inside of these brackets of your quoted string. So we can also use an underscore. So we've used the percentage sign, which means any number of characters. The underscore represents a character, so there has to be a character in that position. Just for this example, I put spaces in there, but you don't need spaces between these underscores, else it will look for character space. But if I put them next to each other, it's hard for you guys to see. The underscore and the percentage sign is what we call wildcards. So if I would code this, obviously now without the spaces, I would find records that start with this number and then has 4 characters afterwards. It will not find cell numbers that only contains the front bit, and it won't find cell numbers that have more than this number of characters. But this here could be characters or numbers. So here's another example. Let's say I was looking for a car registration that had XMB12, and then we're unsure about this character, so this could be any character, and then ending with GP. This is what my code would look like, and it would find, for example, these 2 records where the vehicle registration was stored like that in my database. And then we have the distinct function. So let's say I have a table called TBL learners, and there's a reg class field that holds the register class of each learner. I will have multiple, let's say, grade A's in that field because there's more than one learner in a register class named A. So if I wanted to get just one of each of the register classes, I put distinct before that field name, and that will show me just one of each, like in the example here. And then as you can see, distinct then also sorts it for me in ascending order. I can also use distinct on two fields. So let's take the same example. One of the fields was a grade, and then the next would be a register class. And I want to see just one of each as a combination. So I want to see just one 8A. Even though there are multiple learners in 8A, I just want to see one of each. I will put distinct and then list my two field names here. I will see multiple 8s and I will see more than one A, but as a combination 8A and 9A, I will only see one of each. We are also able to use code to populate combo boxes, list boxes, and radio groups. This is an example of a list box, but you can use any one of those three objects and they have the same properties that you will use in your code. Important is that you would first run a select. So let's say in my usernames table I had more than one of each grade, but I only want to add one of each grade in my combo or in my list box in this case. I'll run a select distinct grade. So now I will see only one of each grade, and remember it will be from smallest, sorted from smallest to largest. So important is that you first run your select statement, and then you want to go query books.first. So what this does is it moves the pointer to the first record in your table that is active at the moment. So if you run your code and you have the table displayed in your DB grid, it moves that pointer right to the top, so that I'm sure I add all the values. Then you will use a while loop to continue to loop through your query until you've reached the end. So this is saying while I've not reached the end of my query, the end of file marker, like you did when you read from text files. And inside here, I'm adding then to my list box, radio group, or combo box by using the code, the name of the object, .items.add. Very similar to richeditor.lines.add, but this time items.add with round brackets. And in here I put the name of my query, a square bracket, and in single quotes I put the name of the field that I want to add. So this will add, for the first time it executes grade 8 or just 8, and then 9, 10, 11 and 12. And then the next line is very important. You need to have a .next. And that moves your active record to the next record. Without this line of code, you'll be stuck in that loop because you moved the pointer to the first record, and now you're saying, well, I've not reached the end of the record. And without moving to the next record, you're never going to reach the end. So you'll be stuck on the first record, and that therefore an infinite loop. Very important is this begin and end as well. So now I'd like you to grab a pen and paper and then press pause and try this. In the next slide, I am showing you the answer. So here's the answer to that question, and there's two options here that you could have used. You could have used the like with a B at the end, or you could also use the right. I know we haven't done that yet, but for those who know it, you can use the right as well. Press pause and then try this one. And here are the answers. You could use a month of date of birth. We're going to do the functions in the next example, but we have done like. Just remember that we need the quotes around the date there. And here's another one. So press pause and try it. And this was a very simple one. We just had to find the category with rows. But remember the double quotes around rows because category is a text data type. And here's the last one. Press pause. I'm showing you the answer soon. You could use your in operator here for flower and rose, and then the color is like pink, any form of where pink appears in the color. So you've learned how to use is null, is not null, the in operator, the like with the percentage as well as the underscore, getting user input, the record count, and using distinct and populating a combo box, which is handy for your pack. To practice these questions, you can download from the education.gov.za site, and then go to curriculum, and then go to National Senior Certificate, and you can go all the way back to 2008. The questions papers before 2014 had the SQL in question 1. So in our next lesson, we're going to have a look at calculations, aggregate functions, how to use group by and having, and also reading from both of your tables in SQL. Thank you everyone for watching, and thank you to Africa Teen Gigs for making this all possible. And follow us on the social media links, as well as look for Africa Teen Gigs in YouTube. Hope I see you guys in the next lesson.